It says photosynthesis reactions in green plants use carbon dioxide and water to produce glucose and oxygen. So a plant has 88 grams of carbon dioxide and 64 grams of water available for photosynthesis. So the first thing it asks us to do is write a balanced chemical equation. So we have carbon dioxide and water. So we're going to have CO2 plus H2O produces glucose, which is C6H12O6 plus oxygen gas, which is O2. So if you remember, this takes place in the photosynthesis takes place in plant cells, in the chloroplast, along the thylakoid membrane, and you have the electron transport chain and all this other stuff, and it gets down to the Calvin cycle that produces the glucose and churns this out. So this is like a very short overview of several processes that happen. But let's go ahead and let's balance this. Let's balance this out. So I got 1 carbon here and 6 over here, so we need a 6 here. And then I have on this side, I would have, let's take a look at our hydrogen. I have 12 hydrogen over here, so I need a 6 over here. So that gives me a total of 6 carbon, 6 carbon. I have 12 hydrogen, 12 hydrogen. Then I have over on my reactant side, I would have 12 oxygens here and 6 oxygen here for a total of 18 oxygens. So I'm going to need a 9 right here. So let's make sure that I have this balanced out correctly. 6 carbon, 6 carbon. I have 12 oxygen and 6 oxygen for a total of 18 oxygen. So there's 18 oxygen over here, plus I've got 6 oxygen there. So it's a good thing I didn't go along with this because this would have been wrong. So if I have 6 oxygen here, so I have a total of 18 on this side. So I need 18 on the other side. If I have 6 here, 18 minus 6 is 12. So I need a 6 here. Okay, so let's just start over again. Make sure we have this 6 carbon, 6 carbon. We're good on the carbon. So then I have 12 oxygen and 6 oxygen. Here I have 6 oxygen and 12 oxygen. So that balances out. And then I have 12 hydrogen and 12 hydrogen. So now we have a balanced chemical equation that we can work with. So it says determine the limiting and excess reagent. I got 88 grams of carbon dioxide and 64 grams of water. So I don't know. Let's just start with the 88 grams of carbon dioxide. So I'm going to see if I have 88.0 grams of CO2, how many grams of water will that react with? So I have to go from grams of carbon dioxide to moles of carbon dioxide, use my molar mass right here to go into moles of oxygen, and then go into grams of oxygen. So I can say 1 mole of carbon dioxide weighs, let's see, carbon is 12.01 plus oxygen, CO2 is 32 for 2 of them. So 1 mole of carbon dioxide is 44.01 grams of carbon dioxide. And I know for every 4 moles or 6 moles of carbon dioxide, I have 6 moles of water, and that's a 1-to-1 equation there. So 1 mole of water weighs 18.02 grams of water. So if I have 88 grams of carbon dioxide divided by 44.01, that gives me 1.9, basically 2 moles of carbon dioxide. Multiplied by 6 divided by 6 is still the same. And then I'm going to multiply that by 18.02. That gives me 36.0, because I'm only 3 significant figures, grams of water that I need. But I have 64.0 grams of water available, which means that carbon dioxide is my limiting reagent. Carbon dioxide is my limiting reagent. And my excess reagent is water. So now I've identified my limiting reagent and my excess reagent. Now I can go ahead and I can determine the mass in excess. Well, it worked out great this way because mass in excess, this one problem, I actually already did that. I have 64 grams of water. I only use up 36 grams of water, so that leaves me with 28.0 grams of H2O in excess left over. Okay? So it says determine the mass of glucose produced. So mass of glucose produced in this one. My limiting reagent is my 88 grams of carbon dioxide. Now I need to go into moles of carbon dioxide. So 1 mole of carbon dioxide is 44.01 grams of carbon dioxide. And then I know for every 6 moles of carbon dioxide, for every 6 moles of carbon dioxide, I produce 1 mole of glucose, which is C6H12O6. And what's my molar mass of glucose? So let's see, oxygen is 16 times 6. So oxygen, 96 moles of oxygen is, or 6 moles of oxygen is 96. And 12.01, 12.01 is 1 mole of carbon. I have 6 of them. That's 36.03. And 1.00 was hydrogen. 1.008, 1.008 times 12 is 12.096 plus 36.03 plus 96. So 1 mole of glucose is 144.13 significant figures. We'll put 4 down there. C6H12O6. So my grams of carbon dioxide cancel out. My moles of carbon dioxide cancel out. My moles of glucose cancel out. So now I can say 88 divided by 44.01 divided by 6 multiplied by 144.1 gives me 48.0 grams of glucose is what I will produce when I use 88 grams of carbon dioxide.